I'm Shinobu Saito from NTT Software Innovation Center. Today, I'll be talking about our recent work on microtask programming in our company. This research is collaboration between NTT and George Mason University. This is the agenda in my presentation. In this presentation, I'm going to give a brief introduction. I'll talk about social challenge in Japanese IT industry. It's becoming hard to procure IT engineers. Then I will introduce our approach, microtask programming. It aims to overcome the challenge. After that, I will share with our case study of microtask programming and the perception of the project participant. Finally, I can summarize my talk. According to a Japanese government report, a lack of IT engineers will increase to 430,000 by 2025. Actually, we have already faced a lack of IT engineers. As you may know, Japan is aging ever faster, so IT engineers will be decreasing more and more in the future. The developing and procuring IT engineers are becoming our urgent task. As you know, there are main two sourcing strategies for finding the right people, crowdsourcing and inner sourcing. Crowdsourcing, by standard definition, recruit IT engineers from outside on demand. It has already been successful. On the other hand, for companies working on crowdsource code with confidential information and intellectual property to protect, they might be worried about security concerns, for example, information leak. We focus on another strategy, inner sourcing. Some companies have begun to use this strategy. They are adapting open source software development practices inside their organization. IT engineers don't belong to a single project. Any employees in the organization can be a member of all projects. This makes the assignment of employees more fluid. However, of course, their main working hours are occupied with the project to which they are assigned. So employees only make use of their fragmented time for inner sourcing. We assume that one key concept to make use of the fragmented time is microtasking. Microtasking is to decompose tasks into short, self-contained tasks. The decomposed task is called as a microtask. Although in-house crowd workers have their fragmented time, they can use their time to contribute the microtask. This is today's presentation summary. First, we report on our web application development project. We arranged the microtasking concept to conduct software construction phase. So we applied microtask programming in the project. Second, we talk about project result. And third point, we describe participant perception on the applied microtask programming project. Let's take a look at our project. The project newly developed an in-house web application system in our company, NTT. The system manages information on finance closing process. The existing system had been operated for 5 years. All participants in our project were employees of NTT. 2 dedicated engineers, requirements engineer, and software engineer are assigned to work full-time on the project. 6 in-house crowd workers joined to the project. Each of them was assigned to different projects. Before our project started, we selected them and we also asked them to make use of their available fragmented time to contribute to our project. Just when you know, their fragmented time dedicated to our project are included in their working hour. Beforehand, we arrange for the manager of the in-house crowd workers to have them make their available time to our project. Therefore, their contribution was done on a voluntary basis. On the other hand, they didn't have additional monetary reward from that. The development process consisted of 4 steps: basic design, detailed design, implementation and unit testing, and system testing. The basic design was completed by the dedicated requirements engineer, and then the detailed design was conducted by the dedicated software engineer. The software engineer decomposed into a set of micro specifications for the in-house crowd workers. In the implementation and unit testing steps, each of the micro specifications are then implemented by the crowd worker. In the system testing, the same software engineers created a test suite and ran them. This is an example of function specification. The function specification was decomposed into 3 micro specifications. The dedicated software engineer created and then sliced them into a set of micro specifications. Each micro specification was separately implemented and reviewed by different crowd workers. In this slide, crowd worker A fetched a microtask on implementing a micro specification 1. The worker A complete the work, push the source code, and create a pull request. Then crowd worker B fetched the pull request and review the source code implemented by crowd worker A. If crowd worker B approved them, he merged the pull request to the repository. Next, project result. This chart visualizes how to make use of their fragmented time. We call it as microtask switching chart. Most in-house crowd workers contribute during the daytime or working for 2 or 3 hours in the evening. The vertical line describes artifact, namely source code. The horizontal line describes time. Each bar in the plot corresponds to a single microtask. Each color indicates in-house crowd worker. As you can see, this chart visualizes pattern path of microtasks. In this project, we have 2 sprints. 6 in-house crowd workers contributed to the project in both sprints. In each sprint, crowd workers are assigned to either front-end or back-end work. The final total line of code is approximately 8,000. About 2,900 LOC, in other words, 36% of the software were implemented by the crowd worker. In total, 50 micro tasks were generated in the project. So the average implementation microtask involved 58 LOC. Let's go on participant perception. We asked the 6 crowd workers to complete a questionnaire. The crowd worker mostly agreed that microtask programming reduced the time required to onboard. They also agreed with the ability to select microtasks. The in-house crowd workers reported that staying motivated was hard. On the other hand, they didn't find the lack of face-to-face communication to be challenging. This slide describes perception by dedicated software engineer. Time commitment of implementation and code review was reduced because 6 cloud workers were working on the implementation review microtask. So the software engineer used the time to prepare the integration test and micro specification for the next sprint. On the other hand, the software engineer reported decomposing tasks into microtasks was not easy. Additionally, conducting integration tests via many small source codes required special attention. I summarize my talk. We recognize 4 characteristics of microtask programming. So we found implications from the applied microtask programming project. This approach can reduce project onboarding and communication cost. Then we think that microtask programming could contribute to improve mobility in human resource management. The potential benefit is to increase the fluidity of project assignment within an organization. However, we have already faced some challenges in terms of technical management and emotion. Deciding the level of detail necessary, aggregating a lot of microtasks, and anticipate when and how crowd workers contribute are not easy. We also deal with how to keep workers with motivation. This is the final slide. In this presentation, we reported an industrial case study of the application of microtask programming to a web application development project. We had realized the potential benefit of microtask programming. In the near future, we plan to develop a support solution for streaming microtask programming. Thank you for your attention.